Welcome back to linear algebra. Let's go ahead and jump into Anki. 2 flashcards. What do we got? What is a homogeneous linear system? A homogeneous linear system is a linear system which all the constants are equal to 0. If A is an invertible matrix, how is the transpose of its inverse related to the inverse of the transpose of A? If A is an invertible matrix, how is it so that it's the transpose of the inverse is equal to the inverse of the transpose? Boom. All right, so I'm going to grade what I did yesterday, and then we'll go from there. All right, we got that problem right from yesterday, so I'm going to continue doing more practice problems, and then I'll be back to recall what I learned here in a little bit. All right, so I finished 24. 24 was expressing A and the inverse of A as products of elementary matrices. 30, we're basically showing that this huge matrix, this 5 by 5, is not possible to invert, or it's non-invertible, so it is singular. Kind of messed up, but I see where we obviously, if it's not invertible, we can't get it into an identity matrix. So I should have here, so we inverted we swapped those rows. What I should have done here is multiplied row 1 through by 1 over b, so I got this 1 up here instead of trying to multiply and then doing it to a 1 over a, and then multiplying it instead of saying negative b to b from a. I can do that, I think, but I should have done 1 over to get the 1s. But eventually we get into this position where we have like b and c in this top row, then a, and then f and g, and then e and h. So we can eliminate h like this, this h is gone. But eventually, like next, we can't get something in this bottom. Because if we try to move this row down, that's going to be out of this f is going to be out of the identity matrix, the central or main diagonal. If we try to add g down here, well, then the f is going to come down here. Well, what can we do to get rid of the f? Maybe we can add this row to get rid of this, but then we're going to have a b stuck down here. Well, how do we get rid of b? We can't get rid of b unless we do negative of this row, which is going to get rid of this again. So this corner is not going to be able to get an entry into it while maintaining the other main diagonal. So we'll call that one good for showing because I got the point. So tomorrow we'll start working on the final proof for 1.5, and then we'll pretty much have another true or false question, and then we'll be into 1.6. So that's it for today. Talk to you tomorrow. See you.